Welcome back to Beginner's Breadboards, my electronics learning journey. Today we're looking at the 6th project from the Arduino projects books. They call this the light theremin. So a theremin is an instrument that makes sounds based on the movement of a musician's hands around the instrument. So the way this is set up is, first on the sensor side, we have a voltage divider here that feeds into the A0 pin or an analog pin. It's using a phototransistor, so based off of the light that it detects, it'll output a voltage, and then you have a 10K resistor here that's grounded. So that creates a voltage resistor that gives a voltage to the analog pin. And then on the other side, we have a piezo buzzer connected to the 8 pin of the Arduino. And so in the code, we're using a function called tone, and that plays a frequency, and we set it to between 50 Hertz and 4000 Hertz. And this pitch depends on the voltage that comes into the A0 pin. So that's all in the code. Also in the code, this one uses a initial calibration to find the minimum and maximum values of the analog voltage obtained by the resistor divider by waving your hand around and changing the light being shined within 10 seconds. So what this initial calibration allows you to do is find a minimum and maximum value for what the phototransistor picks up based off of the ambient light or just any particular environment and how you wave your hand around it. So the way the phototransistor works is if it has more light that it's detecting, you'll get a higher voltage on the analog pin. But if you're blocking the light and it's not detecting as much, you'll get a lower voltage on the analog pin. With that, when it detects lower voltages, you're going to play a tone closer to 50 Hertz. And then when it detects the higher amount of light, you'll play a tone around 4000 Hertz. Between the minimum and maximum values, it can play any tone in between 50 Hertz and 4000 Hertz, depending on the shadows and just the overall light that the phototransistor is able to pick up. So here we have the code for this project, starting with when the sensor is low and sensor is high. These are kind of flipped to what you would typically think to use. So here, sensor low is actually when the analog input is 1023, and sensor high is when the analog input is 0. Further, we're using the built-in LED on the Arduino, which is pin 13. So you're using that as a constant integer. So moving down into the code, this is what is going on during the calibration process. So those first 10 seconds that the code is running, pretty much what this is doing is seeing if the sensor is able to pick up a new high value or a new low value. And so the sensor is constantly sensing during that time. And then if it detects more light, it'll set a new sensor high. And if it has a low light, it'll put a new sensor low. And that creates the calibration and sets those values for sensor high and sensor low. We're also using the serial monitor to print those values there. Further in the loop, this is just the analog read function of the A0 pin, which is the phototransistor, and then you're mapping the sensor value between the sensor low and sensor high that was detected in the calibration, and the 50 and 4000 Hertz, which will be played by the piezo buzzer. And then here's that tone function that plays the pitch that comes from the map. So here's everything built on the breadboard. This is the resistor divider and the phototransistor here that's being connected to the A0 pin. This is the piezo buzzer that is from pin 8. And then there's also the built-in LED on the Arduino that shines over here. So now we'll load the program onto the Arduino. So we'll plug it in the computer, load it from here, and then the program will start. Now we can move our hand around, and this is the calibration process where it'll try to pick up the low and the high. So now it can start playing, and as you wave your hand across, the phototransistor is picking up different values based off the shadows and all of that, and then the buzzer is playing different tones.